G'day. Back on the Gower drill grinder today, and today I'm doing a piece I've been ignoring for quite some time, which is the support plate that the whole angular adjustment thing sits on. It's made out of a bit of 8mm plate, and I can think of a couple of reasons why it would have been made out of that, but it's really a bit excessive. And so I'll flash up the drawing for the original piece, and if you recall, back when the base was made, there was a little appendage bracket on the side there. So if you wanted to go to the original route, that's how you could do it. I'm going to fabricate this just because I can, and I haven't got a piece of 8mm material sitting around the place. This is the piece here. There's the piece of plate that's welded onto the base here, and then this comes out here and has the brackets and bits and pieces on it. It's made out of 8mm plate, I think, just because this was pretty much a prototype, and it was what my uncle had to hand. But not what I'm going to do. I'm going to make it out of a 3mm plate because I've got some of that lying around the place, and when I looked at the part and the design and the drawing, it doesn't really need to be as it is. This is the underside, and this is where the action really happens. There's a bolt there to hold the two, what would you call them, quadrant pieces in, which act as a stop for the amount of clearance you get. There's a hole there for the screw that secures those, and then there's a slot for the pin to go through. That's about all it's doing. Down this end there are just mounting holes, but they're round, that could just be welded straight on, which is what I'm going to do. So to start with, I'm going to be just doing this bit made up of sheet, and you can follow along this way, or you can follow along as per the original if you wish. I've started making some of the components for my fabricated support plate, mainly because they're pretty straightforward. That's just a bit of 25mm diameter steel with an M6 hole through it, and I've made mine 10.5. It should have been 11, but I got the parting on that bit wrong and everything's been made to suit. I've also made this little boss up. This is diameter 16. I've put a little spigot on there because I'm going to drill a hole in the plate and use that to locate that. And it's just another one of those tricks, because I don't need a hole on the outside here, or the top surface. I just need something underneath, and so that's what I'm going to do there. To get the end piece, I've just got a bit of, well, it's a bit of bar, but you could make it out of, if you have some flat, you could roll it. If you had a bit of pipe, you could probably get it out of that, which is, you know, pretty much what I've done. Or you could take that out of a bit of solid bar if you wanted to. I'm going to cut that in half, and that'll be welded on there and do all the stuff there. Then these pieces of flat will go on there, and that'll give me my basic shape. I'm making this a little bit long because I may want to play with the length a little bit, but that shouldn't be a big problem. This was a bit of 50 strip. I've cut that down to 44, and I just used the bench shears for that. They're good enough to do a little bit of 3mm plate. With my odd leg calipers, I marked that out. Now, just as a bit of a trick, if you have to take off a thin thing and strip, and your calipers can't get down that small, what I did was I came in from the opposite side. So I've come along and scribed along there, and then I've come along and scribed along there, and those two lines are 3mm from the edge, which is what you want. So that's always something to remember, is you don't always have to be, you know, from this side and trying to do it. You can come from the opposite side if you've got parallel edges, which is a bit of rolled strip, should be fine. I've scribed a radius around there, and then just nibbled that away with the shears, as well as giving a bit of a scrub on the grinder. That's not going to matter because that'll fit on there and then weld up, so as long as it's reasonably close, that'll be good. I've put a diameter 6 hole there, and I've just bolted my main boss to that, like so. I've also got a diameter 8 hole, which is the size of the spigot on there, and that'll go through there, and then I'll weld that up, and then I can grind that back flush, and you won't see that's there. And then when I come to put in, there's a a circular groove there, but when I come to put that in, I can drill that out, and everything will be wonderful. But by that time, of course, the ring and the sides will be on. So I've welded the two bosses onto the plate. As soon as I had a couple of tacks down, I took that bolt out. It was stainless, but you don't want to ruin a good bolt by just making it red hot. So took that out. I didn't weld all the way around this one because I'm going to have one of these pieces sitting there. So rather than having to dress a bit of weld back, and neither of these bosses are taking much load anyway. Next thing is to put the round piece onto the straights, the flats, and I'll do that as a U-shaped sub-assembly, just so I can get a decent run at it, and then I'll put that on here. I'm expecting there to be a little bit of movement. This was cut from a piece of 20 by 3 flat, and I'm going to use the rolled edge of that, for want of a better term, on the outside, so I don't have to worry about deburring. So just something to think about if you're doing this is that, oh yeah, you can make use of the natural geometry of the parts. It doesn't actually have to be that thick. I'm just making it a little bit thicker than the 8mm on the original, but really in terms of the load it's carrying, you could probably get away with making that 8, but then again you've got the problem of how do you actually attach it. So yeah, it's one of those things. If you haven't, you don't want to use something that's 10. You could do it with a bit less. You could do it with a bit more. It doesn't matter. The only thing you're going to have to do is there's a bolt that goes through there. It's a custom bolt, so it's not just a stock thing, and you just have to adjust your dimensions to live with that. Easy. Just as a bit of a hint, I want to get that so that's basically tangent to my piece of flat. And so what I've done is I've clamped my half round onto a bit of stuff, and then I've just got the square in there. And because both of those points are above each other, it means that when I get this bit of flat in here, it's going to be tangent. So I'll tack that up and do the other side. Fingers crossed I'll have two that are parallel and ready to go. While I'm waiting for my support plate to cool down, I thought I'd do the clearance angle setting plates. There's 2 of them. I've just got a bit of 3mm flat here. Mark them out as per the drawing. It's reasonably straightforward. They're a 2D part. I'm going to start by putting in the 2mm holes, the R2 holes, so 4mm holes, and the diameter 10 hole, the R5. Then I'm also going to put a very small hole through the middle here. I need that for location later on because these things got to be relieved. But so that'll mark that out, and I'll do the holes there, and that means that I can then come along and file and grind and all the rest of it. You could do this on a rotary table. A lot of mucking around, and I did have another plan, but unfortunately that hasn't worked out just yet. So we'll do it the old-fashioned way, the hard way, and just basically cut it out and grind it out and see what happens. Here are my 2 angle setting plates. The first clearance one worked quite nicely. Second clearance one, I had my hole just a little bit too far over, so that looks a little bit wonky, but it doesn't matter because the way these things work is the pin sits between those 2 flat surfaces, so they're radially out from the hole there, or should be. I've done them like this because it's not horribly clear on the drawing, but these things are relieved in this area on both of them, so they sit together and are in the same plane. So that's got to be reduced down to 1.5. That's got to be reduced down to 1.5. So I've left them like that. I'll take them over to the mill. And the way I'm going to do that is I'm going to center on that and then come in with probably a boring bar or something like that, and just come across until I get that clean up that I need. So that's the way you could do it with a file. I mean, if you wanted to, that scribed line there is where the circle ends and should be symmetric. So you could come along with a file and just flatten that off 1.5 millimeters, but I'm going to do it on the mill. Now, what I also want to do with these is have them all set up, and that might mean giving them a very light grind or something like that just to finish them. Because the bolt that goes through, I've already mentioned that, the anchor bolt, that's got a 3 millimeter there, which is to secure these, and that's fine. Because I've now got a bush in there on my version of the support plate, that M10 is going to be longer, so everything gets moved up. But I want to see exactly what these are like before I do that, because you know, I don't want to be in the situation where it's not actually quite right and they're a bit sloppy. They're not a locking fit, but I'd like them to be, you know, firm so that they feel nice and smooth when they move. These two parts go together like that. Now I've just taken these over to the surface grinder and give them a light lick to get most of the worst off. Some of it's not coming off, but oh well. But yes, they go together like that, and you can see the importance of that hole now, because that's the only thing that tells me where the centre is. What I've done here is I've marked the faces that I need to relieve. The steel plus the grinding process has taken this down to about 2.6. Now the drawing says 3, so you know, that's one of the reasons I didn't want to make that special bolt just yet, because I had this feeling it could be a little undersized. That's okay, we can adjust for that, so that's not a problem. What I'm going to do here is I'm going to clamp that down to the table, and then I'm going to bring my boring head in and just traverse that across and get relief there. Now the drawing says 13.5, so 27 diameter, and normally when I use a boring head I'll bore and then I'll check what the bore is and nudge it out a little bit and so on until I get to the size I want. Here I've got a specific size and I'm really using it as a face cutter, so I'm going to do something a little bit tricky, which once again is one of those things worth remembering, just so that I get the right size there. I've set up my vise here to be basically a hard stop. It's just a vertical surface. You could put an angle plate there or something like that. I've zeroed on that face, and then I've come over 13.5 plus 0.5 of a millimetre. And the 0.5 of a millimetre is because I've got a bit of 0.5 millimetre feeler gauge, and that's what I use for doing this sort of setup. So if I have that there, that'll give me 13.5 because of the extra 0.5 there. So all I'm going to do now is just sort of wind the boring head until that sort of starts to grab, lock that up, and that should give me, when that swings, a radius 13.5 or a 27 diameter hole. This is the setup I used to produce my first, what would you call that, counterboard, countersunk, whatever part. That bit of aluminium there, it's only 1 millimetre thick. It's there to backstop the part, because as the milling cutter goes round, it tends to want to push it that way, and just with the one clamp, it will move. I wasn't going to show making the bolt, but I thought, oh well, I might as well, in for a penny, in for a pound. I started off with a bit of bar. I've put a hex on it, a rough spot where I think it's probably going to be needed. First thing was to take that step down to the internal diameter of these holes. You want to machine that so that that is a nice fit there, and I may have to come along in a moment and take a little bit off the back here just to relieve that, but that's fine. There's a relief groove in there, and that's purely for the thread in this part. So I'll take this down to 8mm, which is the diameter for that, and then put that thread on, and hopefully the groove there will cover the unformed thread. The rest of it is 8mm with an 8mm thread on the end here, and once I've worked out where that is, I'll just part that off, and that'll be the part done. So you just need to think a little bit about what sizes need to go where and how it all goes, and that's one good reason to leave this part till pretty much last for this little sub-assembly. Here's the finished bolt and all its weirdness. So there's a diameter there for the sectors to sit on, like so, and there's a little bit of clearance there. Putting this lot all together, the two sectors, adjustment plates, whatever you want to call them, are held in with a special bolt. If that gap there is too much, you could put a shim in there or a bit of paper or something like that just to tighten that up. I think I've got 0.2 clearance between this and the head of the bolt, and that's sort of kind of okay. The M5 screw which clamps this down, I've got a blind hole there, and so I worked out what my depth of thread was, found the screw that was around about that size, and then made up a washer to suit to clamp that down. If you've got the through hole version, you can just cut the screw off, I guess, if you want to do it that way. What you will have to do is do some work on these radii. That's 38 and that's 43, which is basically gives you 5mm size for size on that screw. So if that screw position is slightly out, you will need to adjust those radii slightly. Just a bit of filing, nothing terribly spectacular, but that just sits in there, and that'll clamp that up, and when we come to set that up, that'll be fine. On the top here, the funny bracket goes. Now, when I made this, I left that hole small because I was thinking I might like to use that to scribe the line for that slot. Eventually I set that up on the rotary table and did it, but if you haven't got a rotary table, that's one way of doing that. Put a scriber in there, scribe away. The way the drawings are is there is a height for a centre there and a height for a centre there, so it's just a matter really of finding that and going from there. Now, another thing to point out is that when I did this boss in here, I'm at that diameter 16. It probably could be 12. I had to mill away a little bit of the side there, not that that matters too much, but it could be 12 without any great loss of utility, possibly even 10. So yes, just remember that if you once again, if you go this route, choose your size carefully, because you may want to mill that out. On this side, we have the funny nut that goes on there like so, and then the second handle, and that just does up with a grub screw. I must apologise, the drawing said the grub screw is on this side. I got myself confused, and so yeah, mucked it, but that's okay. And that'll tighten that up and lock that up. I now need to drill that out for the dowel pin that will go through from there through to here. I've got plenty of meat there, so that's not going to be a problem, but that's this part pretty much done. I'm not going to weld it on just yet because I want to check the distance between here and the column. The drawings don't quite add up, and it could well be my maths is not quite good enough, but I just want to check that before I weld that on. But what I was going to do was make up the blocks for the banjo that sits on here, sort out the mounting bracket for the grinder, and then once that had all been done, do a little bit of work with some clamps and things to work out where that needs to be, and devise the position from there. But that works. Happy with that. It's all good. So thanks for watching, and we'll see you for the next one.